So this stuff from yesterday, and Graham wasn't here. Was anybody else in this room not here yesterday? No, you were here. This is probably, like, you guys can choose these formulas at any time to do it if you didn't have your calculator. These are on your formula sheets, these two things, okay? They're not entirely scary or difficult, but you do have to know how the factorial notation works with variables as opposed to just numbers, okay? On your diploma, probably you're just going to shove this in your NPR button, your NCR button, but there will be questions about, with maybe one, about simplifying one of these things. Simplifying it maybe with numbers, like here in example 1, or as we get, I think, maybe the next page, we start to go with the variables, or into things like this, simplifying the expressions with variables in it. Are there some questions from this stuff from yesterday, like you want to see one or two or something like that? Because I know Ms. Weatherspoon taught it, but it is pretty easy no matter who's teaching. It's not really two different ways you can teach it, but I can talk about some. Yeah?
So on page 360, we skipped over example 5. Should do that one? Do you feel like doing it?
Okay, 360. Oh, I'm on the wrong page. Okay. Example 5. Okay, so let's look at this. Is this the page? No, the next one. All right, you just didn't feel like doing it?
Yeah.
Okay. Yeah, it's big numbers, but it's not too scary. On your formula sheet, you guys should know what this formula is here, NCR. So someone tell me what that formula is. I'll just write it here in the beginning of the question. Do this, and it's on the beginning of this package too. So that's it. Okay. So the first number is the N, the second number is the R, and we just put it in. So we're going to look at 400 choose 300 over 400 choose 100, and we're going to simplify it. So I'm going to deal with the top part first, maybe just for some visual. That part's going here. So the N is 400, so we're going to have 400 factorial over, now I got N minus R factorial. N minus R in this case, that's 400 minus 300. What's that? Pardon? 100. So 100 factorial. And then the second part of the equation is saying R factorial, so that would be times 300 factorial. Now, yeah, these are large numbers, and you wouldn't want to start counting down from 400 to try to get to 300 or 100, but you'll see what flushes out at the end. The next part of this equation is putting this part in with the formula. So still N factorial over N minus R factorial, R factorial. On the bottom, what's our N factorial? The top of this, 400 still. So still 400 factorial. And then the bottom now, N minus R, so that's 400 minus 100, is 300, all multiplied by the R factorial, which is 100 factorial. So we plugged it into the formula, simplified a little bit like the N minus R part. Now the next part is to actually divide two fractions, okay? So I have the top fraction divided by the bottom. Grade 8, you learned how to divide fractions. What do you do? Flip the second guy and multiply. So the first one's going to say 400 factorial, 100 factorial, 300 factorial, multiplied by this bottom part flipped, which is 300 factorial, 100 factorial, all over 400 factorial. A lot of stuff to get you excited in this question. 400, 400, divide out to 1. 100, 100, divides out to 1. 300, 300, divides out to 1. So this whole thing equals 1. So big numbers, yes, but once we put it in there, you see things actually simplify. On a diploma, if this was a question, like, well, I wouldn't just shove that in your calculator to get one. But I mean, they could obviously ask, show some kids' mistakes or something like that. Make sense? One thing I guess I just want to touch base on, because some people weren't here. Simplifying something like this. What were you told to do yesterday? I said simplify this.
Expand it until it looks like over there.
Yeah, start with the bigger factorial. So if you're looking, these ends actually mean the same thing, so it's the same number. So the top is actually the bigger factorial. Factorials we learned day one of this unit means start with that number and just keep multiplying by the numbers less than it. So if I started at n, the number less than n minus 1, and then the next one's n minus 2, then n minus 3, then n minus 4. Factorial, because this will keep counting down, but I stopped at n minus 4 because on the bottom is an n minus 4 factorial. And what happens? These are gone, and our answer, although fairly large, would be that. So it's simplified to this, and from there we can actually do a lot of algebra. Even though this is a quartic function, we can do some stuff with it. Got it? Make sense? Any other questions on this sheet? I mean, obviously if you weren't here, it's like, what's happening? But once you start doing a few of them, they're actually not too bad at all. So everything we've done up to this point on our calculator, we could have done with these formulas. Make sense? Okay. Good. Okay, so we're jumping back a few lessons here, much to Christine's dismay. But we're in lesson 2 on page 341, because we talked about permutations, order is important. We talked about combinations, order is not important. And then we're going to look at these guys here where we're kind of mixing them all together. How many arrangements of the word trigonal? How many arrangements of this word can be made if only 2 vowels and 3 consonants are used? Okay? So this is a situation where we're going to be choosing letters and we don't care what order we choose them in, but then we need to rearrange them. Okay, so when we're taking this, looking at this first, we're going to say, you know what? We want 2 vowels. What else do we want? 3 consonants. And we did talk about the importance of trying to break down these questions using these 2 words, and or. In this situation, are we looking for 2 vowels and 3 consonants, or 2 vowels or 3 consonants? This is an and, because the question's saying we want to have both of those. Now, why was that important to distinguish between an and or? Is it multiplication or addition? So and is a multiplication. So when we're looking at the 2 vowels, how many vowels do we have in that word? 3 vowels. How many of them do we want? 2 of them, and we don't care which order they come in right now. We just want to take 2 of them. So 3, choose 2. Our consonants, how many consonants are there? 5. And how many does it say we want? We want 3 of them. So right now in the situation, all this is saying, if these letters were on the table and I multiplied this stuff out, that's how many ways I can choose these. But the question has this word here, where it's saying, you know what, now I better arrange these in specific ways. How many things are we actually choosing, vowels and consonants? 5. How many ways can you arrange 5 things? How do we represent them? 5 factorial. So we take this now and times those 5 things by 5 factorial, because now that would be setting them out on 5 lines and rearranging them. So this is one way you might see it as an answer in your diploma. You might see, remember we talked about this notation as well, which again is outlined on your formula sheet. Another way to write a combination is just in brackets of stacked numbers. If you crunch this out, how many ways can this happen? And that's probably one of the harder things to do. Pardon? 3,600, just to make sure all your brackets are in the right spots and things like that. 3,600 of them. Okay, so we did a combination because we don't care which order we choose them in, but then once we have them chosen, we have to rearrange all their orders. So same sort of situation in this next question. 7 men, 10 women on a committee selection pool. The committee consists of a president, vice president, treasurer. How many ways can exactly 2 men be on this? Now when you see that word exactly, it's a lot nicer than seeing at least or at most, because those questions you have to consider all the cases. So we only want 3 men. And, oh, exactly 2 men, sorry. We want 2 men, and what would be left over? So, 1 woman on this committee, okay? 2 men, 1 woman. We don't care how we select them first. And is multiplication. How many men do we have to choose from? 7, choose 2 of them. Multiplied for the woman, now we have 10 women, and we're going to choose 1 of them. What is 10 choose 1, by the way? 10, if you have 10 things, you're choosing how many ways can you choose 1? You can choose 10 ways. But now, because this line right here, they are going to be arranged in a specific position. So that means I'm going to multiply by how many people on this committee? 3. How many ways can I arrange them in a specific order? 3 factorial. So 3 times 1. So we can see it that way. We can see the combination is stacked. But basically, when we crunch all this out, you get 1,260 different ways you can choose this committee from these kind of restrictions that they place on us. So a permutation and a combination kind of mixed up in one spot. We'll get back to these questions in a second, but we're going to jump into here, and this will touch on the questions you guys had from yesterday that we kind of glossed over. These are formulas that are not given to you. Most of them just sort of make sense when you start doing them. This guy explains these as common things you saw on the Pure 30 exam, and they are somewhat common on the 30-1 in the sense that these are applications of some combinations. Okay? So handshakes, they're saying if you had handshakes or teams playing, because there was one of the questions about teams, and is the number of people or teams that are happening there. And if you think about it, if I had a room of you guys, let's say there was 30 of you, how many ways could you guys each shake hands with each other? Well, there's 30 people, and I need to choose 2 to shake hands. That's how many shake hands. Same thing, if there was 30 teams, how many ways can they all play each other? 30 teams, you need 2 teams to play each other. Okay? Diagonals, we'll talk about these when we get to the multiple combinations. We'll get down into some examples for all of these. So let's rip through these examples. 12 people at a party. Shake hands once with everybody else in the room. How many handshakes can take place? We don't care how they're shaking hands or the order. So there's 12 people. How many does it take to shake hands? 2. So 12 choose 2. 66 different ways these people can shake hands with each other. Number 2. A polygon, and is this the kind of question, the diagonals? A polygon has 7 sides. How many diagonals can be formed? If there's 7 sides on a shape, how many corners are there on a shape? 7. Okay, 7 sides, 7 corners. Kind of like a square. 4 sides, 4 corners. And if you think about a square, let's change this question just at the beginning. There's 4 sides, 4 corners. How do you get a diagonal? You just take 2 corners, and that would produce a diagonal. Or in this case, 2 corners this way, that would produce a diagonal. So I had 4 corners. How many did I choose? 2. So if you look up at what he says, this is going on. He's saying take the number of corners, choose 2 of them. But he says, then subtract the number of sides. Because if we were to look back at our simple example of a square, yeah, this was choosing this line, choosing this. But if I choose 2 corners, I could have actually talked about this side. That's not a diagonal. If I choose 2 corners, I could have talked about this side, but it's not a diagonal. So whatever you're doing, you need 2 dots to make a line, but then you have to subtract the outside part of this polygon because those are not diagonals. So in our case, we have a 7-sided shape, also known as a 7-sided shape, a septagon. Okay? 7 sides, that means I need to take from those 7 sides or 7 corners, I need to choose 2 of those corners, and that will produce all the lines in there, edges and diagonals. So to figure out just the diagonals, I subtract 7. So 7 choose 2 minus 7, and we get 14. Okay. Example 3. If each of the 8 teams in a league must play each other 3 times, how many games will be played? How many teams are there? 8. How many does it take to play a game? 2. So right there, 8 choose 2, that tells me everybody plays each other once. If you need to play each other 3 times, what do you do with this number? Multiply this whole thing, whatever it is, by 3. There's 3 times. So that would be kind of like the question, I think, Austin, you were saying, home and away. So you choose home and away, just times it by 2 once you choose the 2 teams. And you got 84. 15 dots on a circle. How many triangles can be formed? This question is kind of related to here, sort of. Doesn't matter if they're in a circle. The circle just kind of separates them all out, knowing that none of them are just in a straight line or collinear points. If you have 15 dots, how many dots does it take to make a triangle? 3 of them. 15 choose 3. Tough stuff right there. I don't know what that answer is. 455? Okie dokie. And then the last one. How many ways can you choose 1 or more of 12 different candies? Depends on what the candy. You love all the candies. This is one of the ones that I think a lot of you just sort of memorize what's going on. I've never seen this one approach a diploma, but there it is. 2n minus 1. How many items do we have in total? 12. You either choose it or you don't. Remember that question about switches? You either choose it or you don't. Choose it or you don't. Choose it or you don't. So that's each time, each candy has a, I'm going to eat it or not. Eat it or not. So 12 times. But then it says minus 1. Why are we subtracting that 1 case? Anybody know why? Because it's not saying, you know what, we're taking away the case that I just chose nothing. Because it says 1 or more. So there we go. I don't know what this is. 4095?
Yep.
Awesome. So that'll probably clear up some of those questions, Emma, that you saw in that other one. But really, with the exception of this one, kind of throws people for a loop. Most of them you can think yourself through it. And that one about the diagonals, biggest mistake is you forget to subtract the number of sides because those aren't diagonals, but they still are connected by 2 points. So that being said, you have some questions in there right now you should attempt, like after this section and a few before this in lesson 2 with this pros and cons together. Then we're going to start our next lesson here right away. Okay? That's what we're doing.